My presentation will have two parts. First, I will speak you about some telemetry stuff for caping, and then I will make a little presentation of my last digital rig. Before beginning, I would like to give you the name of two guys who are important for me. The first is my brother Jean-Christophe, who lives in the south of France, and with a caper too for many years, and we took together our first picture in 1988, so it's quite a long time, and he wasn't able to come here now, but he builds a very strange, very innovative KAP rigs, and if you have the chance to come in France, it would be very interesting for you to see his rigs. And the second guy is Bernard Chani. Some of you, I think, know him or have already seen some of his pictures on archaeology, especially. And Bernard Noël is a guy who gave me the idea to put an altimeter on a KAP rig and to send the data through the video linking. So I will show you how. So what we can do with in telemetry for KAP, main parameters are: the first one, altitude, then temperature, wind speed can be useful too, and last indicator is compass bearing. And I've had a battery voltmeter, because a battery is often a big problem for caper, and it appears to be very useful to know the voltage of the battery on the KAP. And one other feature is that I use the video downlink to display all this information. At the beginning, I was using a separate LCD display, but as we have now a downlink, it's more simple to use it for that. So I will show you the result. That one. So that's the picture that is generated by the electronics, the electronic stuff. You can see altitude, in meter, direction, so the compass direction in degrees, wind here in meter per second, the temperature, and two voltmeter, one for the one for the cradle, for the radio receiver, and one other for the video transmitter. So this picture can be switched to the video transmitter, and I have a switch on the cradle to choose the camera or this picture. Now, how the electronic board looks like. I turn back to the PC. So that's a picture of the electronic board. So I can show you here. So it's a bit. The board is, I think, 2 inches wide and 3 high. So for the ice measurement, we need a pressure sensor. So it's the part here. Then an analog converter, and all the voltage is converted and is computed with a microcontroller that generates directly the video signal. To have a 1 meter accuracy, the electronic must be very precise, because for one millibar, 1 millibar corresponds to 12 meters. So the precision is 0.01%. Then on this main board, I've had some sensor to make other measurement. First is wind speed. So it's a little sensor with a little propeller, and there is some magnetic stuff on the mobile part, and there is on this little board an inductor that counts the number of turns of the sensor.
So does that use a magnetic lead switch inside in the glass?
No. That's electronic. So that's just the magnetic field generated by the sensor. So that is amplified by an operational amplifier, and then the result is counted by the microcontroller and converted in wind speed. Then the compass sensor. So that's something that appears to me not very useful, but some guys find it not useful to coach and to keep the exact direction and same direction when you do a picture on for archaeological picture, for example. So if the wind change a little, you can adjust to have the same direction exactly. So the sensor is here is a dense more one that's a US company. You can find it on the internet. This sensor is not a full electronic one because there is a small magnetic piece in it, and the position of this piece is measured by two Hall effect sensors. So we have sinus and cosinus, and we can calculate the angle. The drawback of this sensor is that it has to be horizontal very precisely, or the mechanic inside that doesn't give the right position. On the one I have here, I put an electronic compass sensor, so full with no mobile part. That's something you can find too on internet, and this board give the angle directly computed. So through an I2C bus or through a pulse wide modulation, you can have the angle between 0 and...
Is the electronic one affected by metal in the rig?
Yes, this type of sensor are very sensitive to all metallic parts. So it's impossible, for example, to use them inside a house or something. So you have to put them the more far away from metallic part or motors, but there is inside inside the board an algorithm to adjust the measurement. So what you do? Yes, to calibrate. So what you have to do is to make a turn, 360 degrees turn of the cradle, and then the calibration eliminates some errors if you have some metallic part in the cradle.
Olivier?
Yeah.
So are you able to dial if you want the compass to measure magnetic north or true north, or are you able to calibrate it that way? I'm not sure.
Only magnetic.
Is it all magnetic?
Yes, it's a magnetical. This board can be used as a standalone. It's only powered with a 9-volt battery, and the consumption is 12 milliamp, I think. So now I will show you how I have integrated such an electronic in my rigs. So another switch.
Olivier, you have to explain that this is not a camcorder. It's all the
Yes.
electronic device and radio control and so on.
Yes, so that's my remote control for my cradles. So that's a camcorder. I've dropped out all electronic parts, stuff, motors and lenses, and I put in a video receiver, a 2.4 GHz video receiver, and the transmitter, the radio control transmitter to control the cradle. So and I use the switch, the original switches of the camcorder, and of course the viewfinder. The picture is not very good. It's better in the viewfinder. The in focus doesn't like very well the signal I give him.
He has a point in the corner?
Sorry? So the rig is the one here. So 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 on this rig, I added a special chip that is called on-screen display, so that make possible to add the information directly on the picture. So I put in only the main data, so altitude, wind, and the power voltage of the transmitter, and the number of the photo here.
It looks like it's recording the longitude, latitude.
Yes. I'm speaking of it. No. That's not a fix. On the cradle, I will speak about it. On the cradle, I've added a recording function of all parameters when I take a picture. So all data, altitude, wind speed, and so on are stored in a non-volatile memory, and this data can be then downloaded to a PC and be printed and so on.
Is that chip on the rig or in your?
No, on the rig. So there's on the rig RS-232 connector, standard one, and you can connect it to a PC through a standard terminal. What I can say on this picture, the frame here is the frame for the picture, so it helps to have the right the right photo because the angle of the camera is wider.
Generate that frame.
With the same function, the same circuit as the one that write the
So
data.
you just have to describe the coordinates of the
Yes,
box.
yes, yes. So,
That's great.
and then
The altimeter, that's constant, always above sea level, or is that, can that be calibrated to be
No.
above ground level?
now the calibration can be done on ground. When you start when you turn on
It's always zero.
the cradle, yes, it's only 0. You push on a button and it calibrates to 0.
It's changed between 2 and 4 meters, but the camera is in one steady place, that's why I was telling you.
That's the precision of the.
Pressure changing in the room that much.
There's Henry over there. That's my fault.
I can take the blame.
0. Then the last information as so. So here the latitude, longitude, and the GPS altitude. So the number here is wrong because with the roof the GPS doesn't work. So I put it in a simulation mode to have the information that is the information is not steady. No, so that's not that's normal. So yeah. So for the GPS coupling, I will turn on to the presentation. The coupling with the GPS is quite simple because there is in the GPS a standard RS-232 output. The standard is NMEA 183, and so on this link you have all information you need to display latitude, longitude, and so on. What I have added is when I take a picture, the latitude and longitude and other data is recorded as a waypoint in the GPS. So with the number of the photo. So you can after connect the GPS to a PC and download on a map if you have the software that does to do that, the point where you have taken the picture. Through it's through the special protocol of the GPS. So there's a special protocol they define for Magellan GPS, and so you can store waypoint from outside through the RS-232.
So you can use the NMEA and the special protocol at the same time?
Yeah. The result is, I think I have a picture here. Yeah. Oh. So here you have the number of the photo, latitude, longitude, date, time, and well, some other information that are not very useful.
Does the data that you get show which direction the camera is pointing? Does it only
No.
show the location, not
Yes, because the GPS only shows the direction when you move. And well, yes, when you move from a point to another point, so the GPS can calculate the direction between these 2 points. But on a KAP rig, if there's no, you can control the direction. The GPS can give you the direction of the movement of the rig, but the direction of the movement of the rig is not the direction of the picture. That's two different information. That's why the compass, if you want to have the direction, the magnetic compass is the only way. No?
Yeah, GPS models with a magnetic compass integrated.
Okay. You can have a compass integrated in some GPS.
So if you did want to know which direction, you could work that.
Yes, he's got the compass.
Yes. I can give you an example of the memorization of the record that can be made. So after having taken some photos, so I connect the cradle to my PC, and then I have information, number of photos, altitude, and some other data.
How much data can you store in the non-volatile memory?
On this one, 500 pictures. 500 pictures. And for I have another version like this one where I can put 2,000. That's not that's only the size of the memory. That's not a problem.
Olivier, is the camera 35mm or digital? The camera is
Camera on the rig.
Yes. It's mutual.
35mm. Yes.
Sorry.
On this rig? Yeah, film
And-
camera, not this
Yes. That a film camera with very standard one. There's only an electrical
There is a digital.
an electrical release.
How do you control the pan and tilt of the camera? Is that also on the camcorder? The pan and tilt
Yes.
control is that?
Yes. All the control of the camera are on the. Oh, sorry. There's an auto shut off. Yeah. On the
You
top.
rewired the zoom, because the zoom button.
Yes. I use the zoom to control the movement, and some other button. I have a special functions too that is very special. It is the orientation of the antenna, so it's very funny, I think. You can see. That's not very useful when that's not very useful when you hold the line, but when you are under the rig, it sometimes helps to have a picture if you are right under the rig. So that's all for telemetry. So I can turn on my little presentation of my last rig. So that's my first digital rig with a picture here. This rig is controlled with the same camcorder. I just have a switch to switch from one to another. So I switch to the other one. The first version. The first version of that rig was using an Olympus Camedia C1 or CU. That's 1.3 megapixel fixed focal, and now I put an Olympus C220, or in US I think it's C2 zoom. So it's a 2 megapixel with a 3x optical zoom. That's the difference, the main difference. So this cradle has a radio control, so vertical, horizontal, and all function. So every 10 push button of the camera can be controlled from the radio control here. So it makes possible to use all features of the camera. What I can say, there's a video downlink with a small 2.4 gigahertz. It's the one you show, the little one.
From the same phone?
Yes.
That's another one.
Okay. And one interesting feature is the power supply, because there's no specific battery for the cradle, for the electronic and servos. It uses the internal battery of the camera. So there's in the camera 2 AA standard battery. So and the cradle is powered with 2.4 volts.
How long
I never make the test, but I think 1 hour or so with nickel lead battery. I've not had a problem with it.
Do you ever fly both cameras at the same time? One above the other?
I can. Yes, that's possible. But I never used. No. I never used the same. But it's completely possible. I can switch from one to another, and when I switch the video transmitter automatically switch off when the other switch on, or it would make some problem. The antenna is standard. Is the antenna that was with the video receiver. So it's a patch printed circuit board antenna. That works fine, but I don't do modification on it. And then the weight of the rig is 410 grams. The 10 grams are due to the new camera, because with the previous one, that was my goal, I was 400 grams exactly. So best is now to show.
Olivier, how are you able to control all the functions of the camera? You say you can control.
I will speak about it after. That's a little complex. So that's not a good one. The picture is very bad, but. So the picture we see here so is the same as a control screen on at the back of the camera. So with the camera you have useful information as the number of photo you can take, the quality, and when battery are low, you have some information. So you don't need other thing. So to take photos, I can. That's very simple. On this camera, when the picture is stored, the video signal is turned off. That's why. So if we want to see the photo, that's it. And return. Yes. But there's not enough light. I don't. Don't know. It's very bad. No, that's. So I will show you a picture of the. So that's the back of the cradle. So all parts are on the back of the camera. So what we can see is the radio receiver. So I use little board, little modules. That's 434 megahertz in FM. The signal is digital, so there is a special protocol to send 16 bits, so to send all commands. Then here the two servos, one for vertical with a gear and horizontal servos. Both are modified servo without any electronic inside. Drop out it, and they are modified to be able to turn a full round. The servos are controlled by the transistors, electronics we can see here. Then the video transmitter, so it's a Kern 1. It's a 2.4 gigahertz transmitter, 10 milliwatts. It's powered with 5 volts, and its consumption is 50 milliamps, I think. So it works very well. And then I have a DC-DC converter, so to make the 5 volts for the video transmitter and for the other electronic parts. So that's a handmade DC-DC converter with a linear part. That's not a maximum part for it, but that's the same thing. With one chip, one inductor, 2 capacitor, and one diode. It's very simple to build. And then all the stuff is controlled by a microcontroller. So that's a microchip PIC. The exact reference is 16F84. It's a very popular chip for people who do this kind of stuff. And so there is all the software inside to control to decode the radio receiver, controls the servos, switch on, switch offs, video transmitter, and so on. That's it. And then there's a 5-wire to the camera. So there's the ground, the plus 2.4 volts, and 2 signals to control the function of the camera. So just one thing, the Camedia, the Olympus Camedia are cameras that fit well when you do KAP. Especially, they don't have any automatic switch off. So they never switch off. They only go to sleep mode after 1 minute or so, and you only have to push the release button to wake up. So that's interesting. So the camera customization. So that's something, some complex. I put some picture to show what you what you could do, but I don't know if it's very reasonable to do so. So here there's some place in the camera to put some additional parts. Here the connector. Here there's a microcontroller I've added inside. That's the same reference than the one that is on the cradle, and between the microcontroller that you can see here beside the PCB, there are 10 wires for the 10 switches, and for each switch there is a transistor, a surface mounted transistor, and a small resistor, so to command the switch. And between the camera and the cradle, I use a bus protocol that is I2C bus. That's a standard bus with only 2 wires. You can exchange data between 2 parts. I2C bus is a bus you have in your digital camera, in your TV set. That's something very standard.
Did you put a circuit diagram for the camera, or did you have to figure it out without the diagram? The circuit diagram for the camera board?
No. The only way is to have a multimeter and to look for the signal, but it works not too bad. So I will switch on. The one plug another time. Yeah. So with this system, it's possible to control all functions. So have the different menu to see back the photo. So that's not aerial photography. Yes. No, so that's aerial photography, but from the plane. That's Groenland, I think. And what can?
Kite out the window.
I think about it next time. And so with this camera, it's possible to take some little video. So that's something I've made this morning. I will try to show it. Yes. So. So that could be fine on the line of a KAP, but I don't have at the moment any such picture because the cradle is finished only for about some days.
Just to try to understand what I just saw, you pressed a button, and the button went to a microcontroller, produced a state that was communicated to a 433 megahertz radio, which transmitted on 433 megahertz to the camera cradle.
Mm-hmm.
Instructed a microcontroller to go through your custom interface to the camera, affect a switch closure of the buttons to cause the thing to play, which caused video to come out, go through a 2.4 gigahertz radio, be transmitted back to the same box you were holding, and then it was piped out to this projector and we saw it on the screen.
Yes, yes.
Is that right?
Yes, yes. That's quite right.
Is the camera modified? Try to stay.
It's okay.
Are the switches on the camera modified as well to be controlled by the microcontrollers on the rig? Or is there a plug?
No, there's a microcontroller inside the camera that controls the switch, so that controls the switch in parallel of the switch, the manual, the push button.
Did you add the transistors and the resistor to the circuit board, or were they already there? Just added the wires?
So they are glued on the board.
But you did that. Do you do that?
Yeah, yes.
Okay, so that's your modification.
Yes. Here there is 20, more than 20 extra parts, surface mount parts added in the camera. So I must say, if I have any problem with the camera, it will be difficult for the guarantee. No. So then to finish, to show that when I don't do some electronic stuff, I take some photo when I have some time left, but few. So that's a picture I've taken last March during a festival in Châtelaillon with the Olympus C1. And if you want some other information about some subject, you can find some on my website or ask me. I have some schematics here on CD-ROM if you are interested. Don't hesitate.